Yeah, all right. Once again, my name is Collins Isuga, and I'm presenting what summarized all some of the notes that I captured from the short course in also artificial intelligence. So, module one, starting with artificial intelligence, or the history, trends, and its future. So, what is AI? The field of building intelligent agents that perceive their environment and take actions that maximize their chances of achieving the goal. Meaning, if you build your AI model, it's supposed to achieve that intended goal or a specific task. So, the key milestones, the term artificial intelligence was coined at the Dartmouth workshop in 1956. Early AI focused on symbolic logic and problem solving. This era gave way to modern AI, driven by data and computing power. So, we talk about AI versus the human intelligence. AI is often specialized, or maybe it is built to do a special task or one of the tasks, but not all. So, excelling at specific tasks like chess or data analysis, human intelligence is general and adaptive across a wide range of problems. So, the future AI, explainable AI, users want to understand why login was flagged. Ethical AI, AI must avoid bias in fraud detection. So, this one was based on the project that I'm doing of digital ident fraud. Then we have autonomous agents. AI systems act without human intervention, or they are under self-control. Then we talk about the data mining, or which are one of the cores. The shift from rule-based AI to deep learning mirrors the evolution in data mining from simple association rules to complex pattern-based models. Then Howard Gardner's intelligence, the development of AI systems for logical deduction and problem solving is clear parallel to logical mathematical intelligence. Then AI philosophy, the transition from early rule-based AI to deep learning reflects philosophical shift from classical theories to connectionism or neural networks which are trained rather than explicitly programmed. So our digital identity detection project represents modern AI moving away from simple rule-based systems to machine learning-based detection systems. Then module two, it was introduction problem solving in AI. So AI solves problems by formally defining them in terms of number one, states, the specific solution or configuration at any given time. Then you have operators, the actions that can change one state into another. Then you have the goal, the desired final state to be achieved by the AI. So when you talk about the state space search, the state space is the collection of possible states and the operators that connect them. Then we have search algorithm. AI uses search algorithm to explore this space to find a path from the initial state to the goal state. This is how AI thinks or reasons to find a solution. Data mining, many data mining tasks such as finding patterns or classifying data can be seen as a search problem within a complex data space. Then Howard Gardner's intelligence, formulating a real-world problem into a structured framework of states and operators is a clear representation of logical mathematical intelligence. And then AI's philosophy talks about the process of navigating a problem. Space highlights the frame problem where an AI must distinguish between what is relevant and what is relevant to the problem at hand. Then application to the project. Our project frames the fraud detection problem in this way. The initial state, a new user session with attributes like IP address, device ID, and the login time. Then operators, the user's actions such as changing a password, making a transaction, or attempting to access sensitive data. Then the goal state, The final classification of the session as either legitimate or fraudulent. Then module 3, problem solving by search. So we have uninformed and informed search. Uninformed search, we have algorithms like breadth first search and depth first search, where we explore the entire search space without any prior knowledge. They have exhaustive, but they are exhaustive but can be slow. Then we have informed search. Algorithms like A-star search use heuristic, rule of thumb, or educated guess to guide the search toward the most promising solution. This makes them far more effective for complex problems. Then holistics. A holistic function estimates a cost to reach the goal from the current state. A good holistic makes the search faster without sacrificing a the quality of the solution. For example, in pathfinding problem, a simple holistic is the straight line distance from the current point to the destination. Then we talk about the cost data mining. Techniques like clustering can serve as a form of heuristic. By grouping similar data points, an AI can reduce the search space when looking for patterns. Then how it's Gardener intelligence, the ability to visualize and navigate the complex problem space. A key component of such algorithm is part of the spatial intelligence. Then AI philosophy, the use of holistic is a form of stimulated intuition. This relates to the stimulation argument as the AI thought process is highly effective simulation operation such. Then you got the application. Our real-time fraud detection system can be viewed as an informed search. We don't examine every possible combination of user behavior. Instead, we use sophisticated fraud risk score as our holistic. This score, calculated instantly from various data points, allow our system to prioritize and investigate only the most suspicious sessions. Then module 4, it was about knowledge representation and reasoning. So what is knowledge representation? The field of AI dedicated to representing information about the world in a form that an AI system can use to solve complex tasks. Then logic-based representation. We have preposition logics. It is simple where we have true and false statements. Then we have first order logic. It's more powerful, allowing for quantifiers and predicates which enable the representation of complex rules and relationships, such as for all human are motors. It is represented like that. Then we talk about reasoning, the process by which an AI draws conclusions from its knowledge base. It is the core of AI problem solving. So we talk about reasoning in AI systems. We have deductive reasoning and inductive reasoning. Drawing a specific conclusion from a general rule, that is deductive reasoning. Then inductive reasoning, drawing a general conclusion from from specific observations. Then data mining, the output of many data mining algorithms such as association rules are a form of knowledge representation that an AI can use to reason. Howard Gardner's intelligence, the ability to build a structured logical representation of the world and then reason about it is directly application of logical mathematical intelligence. Then AI philosophy, the AI of logic and symbolic representations is a hallmark of classical AI theories, which contrast with sub-symbolic pattern-based approaches of connectionism. Then our application, our project uses knowledge base to store explicit fraud rules alongside our machine learning model. This could include rules like if a user has never logged in from China and is now attempting to, this is suspicious. Our system then uses the knowledge base to reason about the user's behavior. Then module 5, inference in fast logic, inference in the first order logic. Inference, the process of deriving new knowledge or conclusions from existing knowledge using formal rules. Then inference rules in first order logic. Techniques like resolution and modulus points allow AI systems to automatically deduce new facts from a set of logical statements. This is what allows an AI to reason in a human like way. For example, from the statement like all students are smart, John is a student, an inference engine that can use that John is smart. Then forward and backward chaining. Backward chaining, an inference technique that starts from the goal and works backwards to see if the available data can support it. Used in systems like medical diagnosis and financial risk assessment. Forward chaining. This method starts with available data and applies rules to deduce new facts until the goal is reached. Used in real-time monitoring systems and expert systems. Then data mining. The output of many data mining algorithms such as association rules are used as a basis for the forward or backward chaining inference engine. Then Howard Gardner's intelligence, the ability to draw logical conclusions from evidence is essence of logical mathematical intelligence. Then AI philosophy, the ability of the system to reason based on symbolic rules and reach the conclusion highlights and Chinese room argument, which questions whether the system is truly understanding the rules or just blindly following them. Then application, our project uses inference engine to analyze user behavior in real time, or for instance, if the user's device ID suddenly changes and they attempt to reset their password, the system would use forward chaining to deduce that this is a high risk activity and may be fraud attempt. Then reasoning and uncertainty. AI systems must be able to reason and make decisions with incomplete, noisy, or uncertain information. And some sources of uncertainty, missing data, sensor errors, or unpredictability. Then probabilistic reasoning. AI uses probability theory to manage uncertainty. Instead of a statement being true or false, it is assigned a probability of being true. Bayesian networks, these are powerful graphical models that represent a set of variables and their probabilistic relationships. They are used for making inferences and predicting outcomes under uncertainty. Data mining, probabilistic methods are a cornerstone of data mining. For example, naive Bayes classifiers use probability to determine the class of new data point, while anomaly detection often uses probabilistic models to identify outliers. Howard Gardner's intelligence, the ability to reason and make calculated decisions based on incomplete information is part of logical mathematical intelligence. This it involves understanding and applying the principles of probability. Then AI philosophy, the debate on how to handle uncertainty in AI is a key part of modern AI. Connectionism, with its focus on neural networks and statistical learning, is a dominant approach for managing uncertainty in contrast to the rigid, rule-based systems of classical AI. Then module 7, it's all about planning. What is planning? The process of creating a sequence of actions to achieve a goal. It involves defining a start state, a goal state, and a set of operators or actions that can change the state. The planning process, state space search. Planning can be viewed as a specialized form of state space search where the AI searches through all possible sequences of actions to find the valid path to the goal. Then the challenge is planning can be computationally expensive due to the enormous number of possible actions sequences. Data mining, planning can inform the data mining strategy. For example, a business can plan marketing campaign and use data mining or analyze the results that adjust the plan. Howard Gardner's intelligence, the ability to think ahead and create a strategy to achieve a goal, is a critical part of logical mathematical intelligence and can also relate to the spatial intelligence as planning often involves navigating a complex problem space. All philosophy, AI philosophy, the concept of AI planning course of action to achieve a goal is a form of simulated foresight. This links directly to the simulation argument, where the AI is a simulation of rational agent planning to act in a simulated world. Then application, fraud mitigation plan. Our project can use the planning to create a sequence of actions to mitigate a detected fraud risk. For example, if a suspicious login is detected, the system's plan could be immediately lock the account, send a text notification to the user's registration number, uh, require a multiple factor authentication challenge, then flag account to review by a human analyst. Then module 8. Module 8 is about planning and decision making. So what is decision making, or what does it mean? The process of selecting the best action from a set of alternatives. This often involves weighing the potential outcomes of each choice. Then decision theory, a formal framework for decision making that combines probability and utility theory. It helps an AI choose the best action to maximize its expected utility, i.e., the most valuable outcome. Then we have Markov decision processes, a mathematical framework for modeling decision making in situations where outcomes are partly random and partly controlled by the decision maker. Combining planning and decision making, we have synergy. Planning and decision making are often combined in a single AI system. A planner creates a set of possible action sequences to achieve a goal, while decision maker uses probability and utility to choose the best plan for the set. Data mining. Data mining techniques are used to gather the information needed for the decision making, such as calculating the probability of an outcome or the value of a specific action. Then Howard Gardner's intelligence, the ability to make a calculated decision based on rational weighing and probabilities and outcomes in a powerful applications of logical mathematical intelligence. Then AI philosophy, combining planning and decision making is what allows an AI to act as a rational agent. This directly relates the concept of rational agents in AI philosophy, which are systems designed to act to achieve the best outcome. Application, automated decisions. Our project makes automated decisions based on a real-time data. For instance, based on the risk score or probability and the value of the potential fraud utility. Our system can automatically decide whether to block a transaction, trigger, or simply flag the account. Then module 9 is all about machine learning. Machine learning is a subfield of AI focused on building systems that learn from data and improve their performance on a specific task without being explicitly programmed. We have supervised learning, the most common type of machine learning where AI learns from labeled data. The model learns to map out inputs to correct outputs. Then we have unsupervised learning. The AI finds hidden patterns or structures in unable and labeled data sets. This is used for tasks like clustering and anomaly detection. Learning the digital identity fraud problem. The learning process, our fraud detection model is built using supervised learning. We use large label data sets of past user sessions, in brackets, some labeled as fraudulent and others as legitimate, to train our model. The model learns to identify the subtle patterns and features that differentiate the two classes. Then you have generalization. The model's ability to perform well on new unseen data is crucial. A model can generalize to new types of fraud it has never seen before. Applications. The ML model, machine learning model, our primary fraud detection tool is a machine learning model. It learns from the past data to identify new and evolving more forms of fraud. It can, we also use simple models like decision trees for initial interpretable layer or detection. Thank you for listening.